In economics, elasticity tells us how a change in one variable affects the other in a proportionate measure. So for example, if the price of oil increases by 1%, by what percentage will the quantity demanded of oil change? The law of demand tells us that if the price of oil increases, a quantity demanded will fall. Elasticities attempt to measure the magnitude of these changes in a proportionate way. So for example, if there is a 1% increase in the price of oil, by what percentage will the quantity demanded of oil fall? This is very important for analysis because it can answer the question whether total spending will increase or decrease when the price of oil increases 1%. And we want to know whether spending will increase or decrease because we want to know how a change in the price of oil will affect the welfare of people, consumers. With two or more variables, a partial elasticity measures how the change in one variable affects another, holding all other variables constant. So we're going to use the partial derivative that we learned about in previous videos here when we measure a partial elasticity. Here we have an equation for partial elasticity. If x is the variable that we're interested in, then the partial elasticity is the partial derivative of the function, maybe a demand function or supply function with respect to x, multiplied by the ratio of the variable to the function value. And this will give us an elasticity, which gives us that percentage change interpretation that we're looking for. Here's an example where we've got gasoline demand. We've got a demand function for gasoline, and the demand for gasoline is going to depend on the price of gasoline and household income. Let's start with part A. We want to compute the price elasticity, which is defined in our textbook as EI subscript P. So we might want to write our elasticity formula. We're going to have P, which is the changing variable, divided by the function itself. So maybe I'll write this as D as a function of P and I. And it's going to be multiplied by the partial derivative of the demand function with respect to P. So it's going to look something like that. Now we can use the function itself. So we're going to have P for price divided by 50p to the power of negative 0.4. I for income to the power of 0.2. And we're going to multiply this by D subscript P. So I want to take the derivative of our demand function with respect to P. We can do this in parts. I'll put a dP there. And what's dP? Well, dP, D subscript P, I should say, is the derivative of the demand function with respect to P holding I constant. So we're going to get 50 times negative 0.4 times P to the negative 1.4. We're going to subtract 1 off that exponent. And we're holding income constant, so we're going to have to multiply that by I to the power of 0.2. Combining these together, we get P times dP, which is 50, negative 0.4, P to the negative 0.4, I raised to the power of 0.2 divided by the demand function itself, which is 50, P to the power of negative 0.4, I to the power of 0.2. And if we simplify this, maybe what I'll do here is I'll just kind of simplify this where we've got a P here and a negative 1.4p there. I can scratch this one out and then add 1. I've added 1, and then they're going to sort of cancel each other out. The 50 cancels each other out, and we're left with an elasticity of negative 0.4. Or if you think of how you might have learned it in your microeconomics class, economists sometimes take the absolute value and they write it as 0.4. But we don't need to do that. That's just a convention. It doesn't change the answer. How do we interpret this elasticity? Our interpretation here is going to be a 1% increase in the price of gas is associated with a 0.4% decrease in the quantity demanded of gas. Let's complete part B. So that was A. And now B, we can do the same thing. Compute the income elasticity. So we're going to write income in the numerator, write the entire function in the denominator. And we'll do this as one shot, so I'm going to multiply that by the derivative of the demand function with respect to I. So we're going to get 50 times p to the negative 0.4 times 0.2 I to the negative 0.8. And if we do a little bit of simplification, I had forgotten a negative over here. Make sure I had my negative. We're going to be just left with income elasticity of 0.2. When income increases by 1%, then the quantity demanded of gasoline increases by 0.2%. That's how we interpret the elasticity. Suppose we have a price elasticity of negative 0.4. A 1% increase in gasoline prices causes quantity demanded to fall by 0.4%. That's what we concluded on the previous slide. If price rises, does total spending on gasoline rise or fall? Why? Well, spending on gasoline is equal to the price of gasoline times the demand for gasoline. So the percentage change in price times quantity demanded is approximately equal to the percentage change in price plus the percentage change in quantity demanded. So when the price of gasoline increases 1%, the quantity demanded is going to fall 0.4%. We would expect spending to increase by 0.6% approximately. So we can use our elasticity formula to determine that, in fact, although the price has gone up and quantity demanded goes down, there is still going to be an increase in spending on gasoline.